In this video, we will explore the idea of motion, and we will start with the concepts first. And once we go through the concepts, we will start solving the in-text questions. And once we solve them all, we will also start solving the questions that are provided as part of the exercise. So I'll try to keep this video as short as less than 20 minutes. So in case we are not able to complete the concepts or solve our questions, we'll do it in multiple videos. So let's get started. Yeah. So the idea of motion is pretty old, and probably because it's there all around us, right? So we see moving cars around us, we see birds flying, we see the flight of aeroplanes, we see water droplets fall on the earth when it rains, and motion is all around us. And we see something to be in motion, or we see an object to be in motion when it changes its position from one point to another point, right? That's how we identify, or we see that something is actually moving, right? So so it has to move from point A to point B, someplace. It might look easy for us to we can spot a flying bird, we can spot a moving car. All that is easy, but is it actually that easy to perceive motion? If you really think, if you think deep, you'll see that you are able to identifying a flying bird is easy because you are probably finding something in the background or something in the background that is stationary. Maybe there is a tree that is not moving, so it helps you identify that the bird is actually moving away from the tree or towards the tree. So there is always some point of reference which is fixed, which is helping you to perceive that one specific object is moving, right? Like in the case of flying bird. But the fact is, it is not that easy to perceive motion. And if you're curious about this, I would urge you to explore, try this out the next time when you are traveling in a train. Let's say that your train. Imagine yourself to be in a train. You're in a moving train, and your train is actually approaching a railway station. It is trying to come to a halt on a particular platform, right? Now, at the same time, imagine that there is another train on the adjacent track, which is ready to move towards its destination, right? So by the time your train is entering the station and to come to a complete halt, the other train is also going to start any moment and start slowly moving towards its destination, right? So if you just look out, right, as the train enters the station, and if all what you are allowed to do is look out of the window and look into the window of the other train. You're not supposed to see the wheels or the sky or anything. You're just supposed to look through your window and see the other train's window. Can you accurately pinpoint the moment when your train comes to a halt and when the other train actually moves? Or in other words, can you be absolutely sure as to whether is it only your train that is moving, or is it the other train that is moving and your train has come to a halt, or are both of you moving? I would like you to try that out the next time when you are traveling somewhere over a train. You would want to try that out. And the fact is, it's not easy. It's not fast. The fact is, you cannot perceive motion. It's not that straightforward. And the very first person who observed this was the astronomer whom we all know, Galileo. Galileo in the year 1632, he made this observation, and this observation was formalized by Isaac Newton at a later point in time, which we will all go through in the subsequent sessions. But what Galileo observed was, he took the example of a moving ship in an ocean where it is, not where the waves are not very rash, and it is a pretty, calm ocean. And there is a ship, and under the deck of that ship there is a person who is sleeping on his bed. And for that person, there are no windows around him, so he cannot see outside. He just knows that he's inside a ship. So what Galileo said was, for the person at the deck, it will not be possible for him to differentiate whether the ship is actually moving or whether the ship is at still. I mean, on an ocean which is not rash, right? So similar to our train example that we just spoke. So perceiving motion is not straightforward, right? And to perceive motion, you always need to have some point of reference that is fixed, like the tree, which helps you see if the bird is flying, right? Or a traffic signal, which helps you to identify that the car is actually moving away from it, or a building, which makes it easy for you to understand that the cars are moving on the road, right? So the first part is the perceiving motion is not going to be straightforward. The second characteristic of motion is motion is relative in a way that what appears rest to some may not be so from the perspective of another person. And a classic example would be imagine yourself to be traveling with your friend. Think about that you and your friend are traveling in a bus. Both of you are seated, which means that you are actually at rest. But for somebody on the bus stop or on the pavement, for them, both of you are actually moving at the speed of the bus. So relative to them, you are in motion, but relative to you, your friend is actually at rest because both of you are not moving. Right? So in other words, you can say that from the relative position of both of you, your friend on the pavement is actually moving away, right? When your bus starts to move, right? So motion is relative. What appears to be moving to some can be addressed from the perspective of others, and what appears to be approaching you can be something like the same thing can be perceived as being moving away from the other person. So to summarize, you cannot perceiving motion is not straightforward, and the second part is relative, right? Motion is relative. Now, the third part is, not every object moves in the same way, right? Some objects move along a straight line. Some objects take a circular path. Some objects rotate, like, the example of a moon. I mean, the moon moves around the Earth, right? It takes a circular path, whereas the Earth, rotates as well as, revolves around the sun, right? So, but when you fire a bullet, it pretty much takes a straight path, right? So there are all kinds of motions around us, right, on how objects move. And to begin with, in our study, we will start with objects that take that move along a straight line, right? We will start with that. So motions have variety, let's put it that way. So let's start with understanding motion. Let's start with understanding motion of objects that travel along a straight path. And let's take the example of a person who is walking along a straight line. Let's use this as an example to understand the aspects of motion. Now, as we just discussed, for you to be able to identify something that is in motion or that is actually moving, we need a point of reference that is fixed. So let's consider this point where the person starts to move from it. Let's call this point as the origin, and let's consider this person to be taking one step after the other, and he or she is moving in one single direction, right, along this particular line, right, along this arrow mark. Now, what would happen if the person continues to do that after a certain time? Let's say, after time t, what would happen? This person would have, moved somewhere here, right? He would be walking from here. After time t, you can find someone around here, which means that, when something is in motion, when an object is in motion, it covers a certain distance, right? So let's consider this distance to be, yes, right? Let's call it yes. So which means that after time t, any object that is in motion covers a certain distance. So the first aspect is, the distance. When an object moves, it covers a certain distance. Now, let's imagine another person who who also started at the same time from the origin, right? And but what happened was, this person, after time t, you found this person to be somewhere here, right? So if this were to be the case, which means that this person has actually traveled, has covered a longer distance, right, in the same time. Let's call it S dash, right? So this person has covered a certain a different distance, probably because the way they walk is different, right? So this person has covered a distance of S, but this person has covered a distance of S dash, and both has happened at time t. So what can you infer from these two? You can clearly see that this person, the person who's colored red, is actually fast, which means that the speed of this particular person is higher than the speed of the first person. So here comes the second aspect of motion, which is like, now along with the distance that an object covers as it moves, it also covers that distance at a certain speed. So how do you calculate speed? So speed is the distance covered by the time taken, right? So here the distance S is equal to whatever it is, right? Whatever the distance is. If this person is covered 10 meters here, and which means that it is 10, and if t is equal to 10 seconds, then it means that your speed of this person is going to be 10 over 10, right? Which means that this person has covered 1 step per second. Similarly here, if you consider this distance to be 15 meters, so in this case your speed of this person is going to be 15 by 10, which is 1.5 meters per second. So the speed of this person is high, right? So these are the two concepts, right? Which is your distance and speed. Now let's take a slightly different scenario. And in this scenario, let us consider the same two people. Let's consider this person who's traveling, who's moving from point A to point B, right? Who's moving along this direction, and we also have the other person start from the same origin, right? From here, right? Oops, I took a different color. Let me see if I can be, yeah. Okay. So let's say that both these people are walking along a straight line, and let's consider that this person has at time t, right? At time t, this person has reached this point, which is 10 meters, and we also see that this person has also reached the same point, which is 10 meters, right? And let's take a time t1 after even more times, right? Time t1. Let's say that this person, you find them here, right? Which is probably 20 meters. But at time t1, you observe that this person is gone. He has only reached here, which is probably 15 meters. Right? So this is time t. So this one is time t, and this one is time t1, right? So these two. Now, what can you say about this? So both of them started at the same time. They moved, at time t they covered the same distance, which means that their speed has been the same. And but after that, possibly if you consider this to be if you consider t to be 10 seconds and t1 to be 20 seconds, which means that if this one is considered to be 10 seconds and this one is considered to be 20 seconds, what can you can clearly see that the speed of this person has remained the same. The speed of this person has been uniform throughout, but whereas the speed of this person has been non-uniform, right? So this person has been uniform till here, but he has slowed down, and it has been uniform between this. But overall, the speed has not been uniform. So what do you call such objects are So these objects are traveling with a uniform speed, and this object has actually traveled at a non-uniform speed. So when an object travels with a non-uniform speed, what you can do is you can calculate the average speed. If you really want to find the distance covered by this person from the origin till here, what you would need to do is calculate the average and speed. And how you calculate the average speed is equal to the total distance that is covered divided by the total time taken. So in this case, your total distance is going to be 10 plus 5, which is equal to 15, over the total time, which is going to be 20 seconds, which is 3 by 4, which is equal to 0.75 meters per second. Right. So this is your average speed for this person. Now, one aspect about all these quantities, speed, distance, and speed is, if you notice, I have used this, I've called this as, meters per second. So this is the unit for speed. So typically, in any physical quantity, which is, distance, speed, or anything that you're going to learn has a unit. You're going to measure that in certain units, right? And there are many different ways that you can measure. For instance, your distance covered. Your distance covered can be measured in kilometers, meters, feet, miles, and all that, right? So for us to be consistent in all our conversations going forward, we will use a system called the SI units, the international standard for units. And in the SI system, distance is always measured in meters, and time is always measured in seconds. So which means that your distance is always measured in meters, time is in seconds. So your speed, which is distance over time, is going to be measured as meters per second, or ms minus 1. Right. So I think we'll pause here. We'll close it at the 20-minute mark, and we'll continue in our next video. Thanks.
One final thing before you leave. If you wish to revise the concepts that you've just learned, please look up and try out the free Revise app bot on Telegram app. Telegram is available for free on both iPhone and Android. Also, if you did like the content that you just watched, please do like, share, and subscribe this with your friends. Thank you.